Okay, let's take a look at our last example, example 9. We are almost done. Hang in there for this one more example in this application section. So we want to look at this idea because, we are talking about rates of change. How can we use derivatives and in economics and in things that are more important to us, like how do we make money? A couple of things to look at is that we have a couple of ideas: marginal cost, marginal revenue, marginal profit. These right here, you've probably heard in the online economics personal finance class if you've taken that. And you've heard them before. And loosely, marginal cost is loosely defined as the extra cost of producing one more unit. But in marginal revenue is the extra money brought in from selling one unit. Marginal profit is the extra profit. But what these really are is this idea, because most of the time you are not going to know a cost function, a revenue function, and a profit function. What you are going to know is some information about the derivatives, how fast these things are changing. These marginals are nothing more than derivatives. The marginal cost is the derivative of the cost function. The marginal revenue is going to be the derivative of the revenue function, and the marginal profit is going to be the derivative of the profit function. So it's this idea of at any given instant, we can look at how fast our cost is changing, whether the cost is increasing or decreasing based on what we're seeing currently in today's trends, and use that to help us make some predictions about, do we want to make more of these items or less of these items? We're going to make more money, what's going to be going on? And remember, profit is revenue minus cost. And there's another thing which you may or may not have seen before. It's called the average cost, which is where you would simply take how much it costs to produce, say, 10 units, divide that by 10, and that will tell you your cost per unit when you're looking at it. So basically taking a look at this, we're going to do an example. And in this example, I've given you a cost function, I've given you a revenue function, so we can just play around with this a little bit. And your shop is currently producing 10 radiators per day. So we want to kind of make some decisions based on what we're doing and what we're seeing with our cost and our revenue functions. The average cost of producing our functions is simply more just, knowing the formula. So our average cost is going to be C of X, the bar over it, like, it's like X bar, like when you do average, we'll use that, which means that we're going to take C of X and divide by X. That's my formula from above. So the average cost of producing 10 radiators, I'm going to take the cost at 10 and divide by 10. Now I'm going to assume that this is a calculator problem. And so what we're going to look at, I went ahead and I put into our y equals, here was my cost function in y1, here's my revenue function in y2. So let's go back to the home screen. And so I need to calculate my cost. So alpha F4, cost was in Y1, and I'm going to take my cost at 10. And the calculator does function of notation for us. It's not going to take that times 10. This is F of 10 using the cost function divided by 10, and I'll let it tell me, so we get 55. And so when we write that down, 55, what are the units? Because they are going to ask that. It's dollars per unit. So dollars per unit is going to be our average cost. All right. Now, our profit of producing and selling 10 radiators, our profit formula, P of X, is going to be found by taking our revenue minus our costs. Pretty straightforward. So I'm just going to calculate P of 10 by doing R of 10 minus C of 10. Again, I'm going to use the calculator for this. So let's come back to the calculator. Alpha F4, again, revenue was in 2. Y2, so Y2 of 10 minus alpha F4, Y1, enter, of 10, and enter, and that's going to give us 270. All right, so we'll write that down. So equals 270, and our units for that is going to be dollars. $270 is our profit that we are gaining by selling 10 radiators. All right, not a great profit. It's not, so we've made 10 radiators, we put so much work into it, we have made $270. It's not a great business going right here. Can't live too much off of that. All right, now the next question, what is the marginal cost to produce one more unit? Marginal cost is our derivative, C prime of x. So what we need to calculate then is C prime of 10, because we are currently producing 10 units, so we want to see what's the cost of producing more. So we're going to take a look at basically the tangent line to the cost curve to help us figure out what the cost to produce one more unit. So this C prime of 10, again, and I'm going to do this on the calculator because we're going to allow the calculator to do a lot of this. I'm not really worried about doing it by hand right now. So we take a look at this, and so the derivative, remember that's under the math menu. So I want to do number 8. I want to take the derivative with respect to x of the cost function, which was in y1, so alpha f4, choose y1, and we want to calculate that derivative at 10, enter, and that's going to give us about 195. And so, and in terms of our units, what are the units of this? Remember that this is the derivative of the cost with respect to x. So we're going to have dollars per unit. Dollars per unit is going to be the units of the marginal cost. So if we were to produce one more radiator, we would predict or say that we would make around $195. That would be the cost, not what we make. That would be what it would cost us to make that one more radiator, another $195. So you might be looking at this going, well, my profit right now is only $270 and it's going to cost me another $195 to produce this unit. Then maybe I don't want to do that. Also, one thing to look at is that this is just an estimate of the actual real cost. The real cost for producing, and this is one of the things we don't usually have the cost function to calculate it, but just to give you an idea of why we can use this marginal cost, the real cost would be C of 11 minus C of 10 over 11 minus 10, because that's the cost to produce one more unit. And we can do that on the calculator. And I already did it, and you can type this into your calculator yourself. That's going to be $220 per unit. So this is the actual, this is what the derivative gave us as an estimate. Now, what we're going to see on this is I went ahead and I graphed for us, this is your cost curve right here. And you can see that my cost curve is increasing and concave up. And then my tangent line is what I graphed right here. And if I hit trace and we go type in 10, then so you can see right here that my tangent line falls below the curve because the curve is concave up. So this idea of, is this a good estimate? Well, it's a fairly good estimate. This is an underestimate. C prime of 10 is going to underestimate the real cost to produce one more unit additional unit, because C of x is concave up, so the tangent line is below. Tangent line is below. And so that idea is the slope of the tangent line is giving us the additional over one unit up $195. It's not quite up as much as it would be because of that. It's a little bit of an underestimate, but it's a close estimate, so that's why we use this marginal cost. Marginal revenue is going to be our R prime of x. And so, and again, that's dr with respect to x if we write it that way. So using our calculator, we calculate R prime of 10. And, so let's go over here. Second, go back to my home screen. So I need the revenue. That was in Y2. And so my revenue, I forget what I was doing. Oh, that was my actual cost. Oh, you know what? Hold that thought for just a second. Let me pause. I confused myself. That was my profit up there. All right, so now I need to do my marginal revenue, which is my derivative. So math 8, and then I want to do with respect to x, except we're going to be in Y2 this time because it's the revenue, so 2, and then at 10. So we enter that and we get about $252. Okay? So approximately $252 per unit. Okay? And again, now is this going to be an over or an underestimate? Well, what I'd have to do is take a look at my, oops, wrong one. Let's go to this one. If I go to my y equals, I'm going to turn off my cost function, turn on my revenue function. Let's see how lucky I am on that. There's my revenue function, and that's the wrong tangent line. So ignore that. But if I look at, I am definitely concave up. So that's going to be an underestimate as well. So this is going to underestimate the actual revenue that you're going to take in. Now, taking a look, now we might ask the question, should we begin producing and selling 11 radiators instead of 10 radiators? Now let's kind of talk about our reasoning and why or why not we would not do that. We might look at this idea that our marginal profit, since the derivative is your marginal profit, P prime of X, is simply R prime of X minus C prime of X, the marginal revenue minus your marginal cost, 252 minus where's my 195, and again, I know that's the actual, but we'll use the marginals. 252 minus 195 is going to be $57. So P prime of 10 is about $57. So even though it cost me about $195 to make that additional radiator, I make $252. So I'm going to gain an additional profit of $57. So we might want to go ahead and say, yeah, I really want to do that because I was only making a profit of $270. So now if I do an additional $57, that's going to be even better for me. But there are other factors that you do have to consider for this. Even though our marginal profit looks pretty good compared to what we're making right now in profit, what other factors might be something that we need to think about? Maybe the reason that I'm producing 10 radiators right now is because my labor force can only produce 10 radiators. And if I want to increase my output, maybe I need to hire an additional staff member to come in to allow that to happen. And then the cost of hiring that additional staff member may change this idea of this marginal profit. This marginal profit is given this idea that I don't have to change anything else. I might also have to have new equipment. I may have to have new capital, like where I take and I need another machine that's going to help out. So I may need to renovate my factory in order for that to happen. I would have that additional cost. So there are other things that play into this than simply looking at this snapshot in time of, provided nothing else needs to change, what would happen to my profit if I increase it. But there are other things that would affect it. And that's why, the economics part of it ends up being a little bit more complicated than this kind of mini example that we have. But these are some of the things that they look at and how derivatives can be used to help us examine business situations with our profit and our costs and our revenues to see what we're going to do. All right, so we'll end that up, and that'll be the end of the rates of change and the particle motion notes. And you'll begin working on the worksheet in class next time. So don't worry about doing that for homework. Your homework was only to watch these videos.